For years, almost everybody believed the same thing. They believed the United States was finally winning the fight to cut itself loose from Chinese manufacturing. Tariffs were going up, factories were coming home, politicians were standing in front of half-built battery plants promising a new era of American industry. And on paper, it looked like the plan was working. Here is the problem. It was not working. Not the way anyone thought. Because while everyone was watching the ribbon cuttings and the groundbreaking ceremonies, something else was happening quietly, underneath all of it, in places nobody was pointing a camera. And that quiet thing is the reason this story exists. This is not a video about politics. This is a story about supply chains, about materials, about the parts of modern industry that never make it into a press release. It is about how the country that tried hardest to walk away from China ended up finding out just how deep that dependence really goes. Let us start with the part everyone got right, because there was a real reason people believed independence was coming. The United States passed the CHIPS Act, pouring tens of billions of dollars into domestic semiconductor production. It passed the Inflation Reduction Act, designed to build an entire clean energy supply chain on American soil, from electric vehicles to solar panels to grid batteries. Tariffs on Chinese goods stayed in place and in some cases increased. Companies started talking about reshoring and friendshoring, moving production to Mexico, to Vietnam, to India, anywhere that was not mainland China. For a while, this looked like a genuine turning point. New factories broke ground in Georgia, in Arizona, in Ohio. Executives stood at podiums talking about bringing jobs home. And if you only watched the announcements, you would have every reason to believe America was quietly untangling itself from Chinese industry, one groundbreaking ceremony at a time. But here is the twist. While the United States was busy building the visible parts of the supply chain, the final assembly, the shiny factories, the ribbon cuttings, it was not building the invisible parts. And the invisible parts turned out to be the ones that actually mattered. Think about a battery. When you picture a battery factory, you probably picture the final stage. Rows of machines stamping out finished battery cells ready to be shipped into an electric vehicle. That is the part America built. That is the part that shows up in the press conference. But before a battery cell can be stamped out, it needs raw materials. It needs processed lithium, refined cobalt, graphite, and chemical precursors. It needs machinery calibrated to extremely specific tolerances. And it is at that earlier stage, the stage nobody photographs, where China still dominates almost completely. According to the International Energy Agency, roughly 80% of the entire world's batteries were manufactured in China as of 2024. Not 80% of one component, 80% of the batteries themselves. And when you break that number down step by step, from raw material processing to cell assembly, China controls somewhere between 60% and 100% of every single stage along the way. Let that sink in for a second. A car with an American badge on the hood, built in an American factory, sold to an American driver, can still be running on a battery whose entire life cycle, from the mine to the finished cell, passed through Chinese industry at almost every step. The final assembly might say "Made in America." The material reality tells a very different story. And it is not just batteries, it is the materials that make modern technology possible in the first place. Rare earth elements, the group of minerals used in everything from electric motors to fighter jets to wind turbines, are not actually rare in the ground. They are common. What is rare is the ability to process them into something usable. That processing, the refining, the separation, the transformation from raw ore into industrial-grade material is a chemical and engineering capability that China spent decades building almost uncontested. The same is true for permanent magnets, the components inside electric motors that make them spin with incredible efficiency. You can mine the raw materials almost anywhere, but turning those materials into a finished magnet, at the scale and cost the auto industry needs, that capability lives almost entirely inside China's industrial ecosystem. This is the moment where the story stops being theoretical, because it already happened in real time. Reuters reported that Chinese export restrictions and new licensing requirements on rare earth materials disrupted production schedules at automakers and semiconductor companies around the world. Not disrupted in the sense of a headline, disrupted in the sense of assembly lines slowing down, shipments getting delayed, executives scrambling to find alternative suppliers that, in many cases, simply did not exist yet. So here is the real question this story is built around. How did the country that tried the hardest to reduce its dependence on China end up discovering it needed Chinese industrial capacity even more than before? The answer has to do with speed. Industrial policy moves slowly. You cannot build a rare earth processing facility, get it certified, and scale it to commercial volume in a year or two. It takes a decade, sometimes longer, and it requires expertise that does not simply appear because a government wrote a check. Meanwhile, demand for batteries, for electric vehicles, for grid storage, for the entire electrified economy exploded far faster than anyone expected. Add the sudden global appetite for artificial intelligence hardware, which requires enormous amounts of electricity, specialized chips, and supporting infrastructure, and you have a demand curve that shot straight up while the supply side of critical materials crawled forward at its own pace. The United States was, in effect, racing to build a house while still waiting for the lumber yard to open. Assembly plants could be built relatively fast because assembly is, in industrial terms, the easy part. Refining rare earths, producing battery-grade chemicals, manufacturing specialized industrial equipment, that is the hard part, and it takes real time to build from nothing. This is where the companies come in, not as villains, but as evidence. Tesla, Ford, and General Motors all depend on battery materials, cathode chemistry, and rare earth magnets that trace back into Chinese supply chains, even when their final vehicle assembly happens on American soil. That does not mean these companies made a mistake. It means they were operating inside a global industrial reality that nobody built overnight, and nobody can undo overnight either. On the other side of the equation sit companies like Saddle and BYD, Chinese battery and vehicle manufacturers that became global benchmarks, not because of luck, but because of decades of concentrated investment in exactly the industrial depth the rest of the world is now scrambling to replicate. Apple, Amazon, Microsoft, and Nvidia depend on China in a different way, through manufacturing ecosystems, component suppliers, and electronics assembly networks that took decades to build and cannot simply be copied and pasted somewhere else. Companies like Foxconn and TSMC sit in the middle of this story, representing the electronics assembly and semiconductor manufacturing capacity that ties American technology brands into a global web stretching across Asia. Meanwhile, firms like Siemens and ABB show how even industrial equipment makers from Europe are wound into the same interconnected system, supplying and competing with Chinese manufacturers at the same time. Here is what makes this story different from a simple tale of winners and losers. The United States has not fallen behind everywhere. In chip design, in cutting-edge research, in software, in artificial intelligence model development, American companies remain firmly in the lead. This is not a story about America losing its edge in innovation. It is a story about discovering that innovation and manufacturing depth are two completely different muscles, and building one does not automatically build the other. Think of it this way. Designing a battery chemistry breakthrough in a lab is one achievement. Manufacturing that chemistry at the scale of millions of vehicles a year, using refined materials produced by an industrial base with decades of specialized experience, is an entirely different achievement. The United States has plenty of the first. China has built an overwhelming advantage in the second. And this is the part of the story that stays hidden from most people, because it is not designed to be visible. A product does not come with a label listing every material's country of origin at every stage. When you buy an electric vehicle, a solar panel, or a home battery system, you are looking at the last stop on a journey that likely began with Chinese mining, Chinese refining, and Chinese chemical processing, even if the box says the final product was assembled somewhere else entirely. The International Energy Agency put a number on just how deep this hidden dependence goes. Nearly all battery energy storage systems installed outside China, and more than 70% of electric vehicle batteries used outside China, could not currently be produced without Chinese-made batteries or Chinese-made battery components. Read that again. Products marketed as American, European, or built anywhere outside China are, in the overwhelming majority of cases, still structurally dependent on Chinese industrial capacity to exist at all. So what happens next? Can the United States actually close this gap? In some areas, yes, and probably within the next decade. Final assembly, some semiconductor packaging, certain categories of electronics manufacturing, these are areas where American and allied capacity can realistically scale up in a reasonable time frame. But in the hardest categories, rare earth processing, permanent magnet production, advanced battery material chemistry, the honest answer is more complicated. Fully replacing Chinese capacity in those specific layers would require sustained investment over many years, coordinated cooperation between the United States and allied nations, and very likely higher costs passed down to consumers for the foreseeable future. This is not a problem tariffs alone can solve, because tariffs raise prices without automatically creating the specialized industrial expertise sitting on the other side of the world. Here is the provocative question worth sitting with. If the country that leads the world in chip design, in software, and in artificial intelligence still cannot manufacture a modern battery from mine to finished cell without leaning on Chinese industrial capacity, what does true independence in the 21st century actually look like? Is it even realistic to expect any single country to control every layer of a global supply chain this complex? Or is the real endgame something closer to managed interdependence rather than full separation? That question does not have a clean answer yet, and honestly, nobody fully knows how this plays out over the next 10 years. What we do know is the story people were told. The story of steady independence through tariffs and reshoring was not the full picture. The full picture is messier, more layered, and in some ways more interesting, because it shows how modern industry actually works underneath the headlines. If this is the kind of story that changes how you look at the car in your driveway or the battery in your garage, stick around, because the industry is moving faster than most people realize, and the next shift could hit closer to home than you think. To make sure you are not caught off guard by what is coming next in this industry, join us here at Driven to Distraction.